Exponents. So we looked at exponents briefly last class, and let's take a look at, say, 2 to the third power. That means to take the base 2 and write it down 3 times and multiply. Now I'm not multiplying 3 times, I'm just writing the base 3 times. So the exponent isn't how many times I multiply, it's how many times I write the base. And then I multiply. If I'm lucky. So 2 to the third power, 2 times 2 is 4, that's 1 multiplication, times 2 again is 8, that's 2 multiplications. There are only 2 multiplications here, right? 2 to the second power is just 2 times 2, right? Take the base, write it twice, that is 4. What about 2 to the first power? Well, that says write 1 too, but I don't get to multiply. It's always kind of a disappointment. But I wrote the base down. So again, super important. An exponent is a base to a power. And it just basically tells me how many times to write the base. It's not the number of times I multiply. So, if I wanted to multiply, I could say, well, I could say that's 2 times 1, which is 2. And then that brings me to the idea of 2 to the 0. Should that be allowed? Well, there's an interesting pattern here. With the exponents, I jumped from 3 to 2, so the exponent dropped by 1 here in my table. And then I jumped from 2 to 1, that's another drop of 1. And then that 1 dropped to a 0, so I keep dropping the exponent by 1. And Monsi says the answer ought to be 1, okay? And I think that's an excellent idea, especially when I look at the pattern on the other side. What pattern do I see that takes me from 8 to 4 when I do the same thing to get from 4 to 2? Well, going up, I'm increasing the multiples. So going down, I must be dividing out a multiple. So when I move down this table, I'm dividing by 2 on each step. And if I take 2 and divide by 2, I get 1. Yeah, so it turns out 2 to the power 0 is 1. Cool thing about that idea, which is kind of wild, is it doesn't matter what the base is, really. So for example, if we had 3 as our base, 3 to the third, 3 to the second, 3 to the first. Let's do those first. 3 to the first is pretty easy, that's 3. 3 times 3 is 9. Multiply by 3 again and I get 27. When I move up here, I'm multiplying. When I move down, I'm dividing by 3 in a sense on the right side. So then 3 to the 0, the pattern is, well, it should be a 1 for this pattern to hold. And again, we can kind of think about it the way we did in the other table. As we move down this table, the answer is essentially divided by 3, divide by 3, divide by 3. And so 1's kind of a natural progression there. Now, we're not into negative numbers yet, but what if we went one more time here, just for fun? Let's do this one over here. What if I tried to continue this pattern? 3, 2, 1, 0. What would the next power be? Any thoughts? Negative 1? And on the other side, if it really means divide by 2 every time, well, 1 divided by 2 again would be 1/2. So this says 2 to the negative 1 should be 1/2. If we tried that with the 3's, we would get 3 to the negative 1 equals 1 divided by 3, or 1/3. Okay, so notice 2 to the negative 1, I ended up with a 1 over 2. 3 to the negative 1, I ended up with a 1 over 3. The pattern's not always obvious to people, but what's going on here is it turns out a negative exponent doesn't make the answer negative. So So negative exponent. Sorry, this isn't actually part of this section. We're going to get to this in 2 more chapters, but I couldn't resist because you probably saw it before in another class. Exponent means, and the simple explanation is just flip the base. This is what's happening here. And we will come back to that later in the course. There were some properties of exponents that I put in the homework that I hoped you were familiar with. An exponent means repeated multiplication. So if I have something like 2 to the 3rd power and I multiply that by 2 to the 5th power, this one right here says you get write 2 down 3 times and then multiply. This one says multiply, write down 2 down 5 times and then multiply those guys together. So altogether, I have 8 2's multiplied. So that would be 2 to the 8th power. And the connection between the 3 and the 5 is, well, on a good day, 3 plus 5 is 8. And so one of the rules you learned a long time ago is that if you multiply 2 powers with the same base, then you get a shortcut rule where you can add the powers. Why can you add the powers? Because exponent means repeated multiplication. It's as simple as that. When we break it out, we get 8 2's, which happens to be 3 and 5 more. So we have this rule, multiplying by the same base leads to addition of powers. So there were just some homework questions in the next homework assignment that review exponent rules that you may have seen in the past. And it turns out every one of those rules is based on the fact that exponents mean repeated multiplication. We can break it down to that. Those are the big ideas I wanted to talk about with exponents. The next thing I want to talk about is order of operations. And the order, just a reminder, looks like this. Usually it says the number 1 thing to do in the order of operation is parentheses. And what that really means is when you see parentheses, maybe there's something to do inside. The next order of things to do are, if you see exponents, you should do those next. Not much I can say about that. There's an exponent, we know how to do exponents. 3, I mentioned last time, I was a little miffed about as a kid because my teacher wasn't really clear about it, or at least I thought they weren't clear, maybe I just wasn't paying attention. The next one is my teacher I recall my teacher saying multiplication and division. But what I came to realize later in life, it's really multiplication or division. And not because there might not be division there, it's that you have to do them left to right. And that was supposed to be a little parenthesis here on the side to bring that together. So in a string of operations, if multiplication comes first, do it first. If division comes first, you better do it first. You got to do it left to right as you read. And that's kind of a good general rule for the order of operations, except for the idea of parentheses. All right, and then the next, which again, I came to the same conclusion later in life, it's not addition and subtraction, it's addition or subtraction. It depends which comes first. And the left to right thing is really, that's because in this culture and in a lot of cultures, we read left to right. So we start looking at a problem, we look at it left to right. And so that's the way we do it. But why do we have this 1, 2, 3, 4 parentheses, exponents, multiplication or division, addition or subtraction? Well, why can't we do addition or subtraction first? That's easier, right? Well, it turns out because it's easier, that's kind of why we have to do it last. So the reason that the things are in this order is, it comes back to the way numbers developed, right? we first learned how to group things together, and then we gave a name to those common groups. Like I have 5 fingers, I have $5, I have 5 pencils, right? That's the idea of 5, right? Having 5 things. So we gave 5 this name, 5. Then we learned to take 5 things and put them together with another 5 things and get 10 things, which was addition, but sometimes things go away, they get lost, or we share them, and so subtraction comes up. So addition and subtraction are kind of the most basic thing you can do with numbers. Well, where does multiplication come from? What is multiplication anyway? What's our most basic definition for multiplication? Anyone?
Repeated addition?
Yeah, it's repeated addition. That's where it comes from. Division is repeated subtraction. So it's more complicated than addition or subtraction. So addition and subtraction are at the bottom because they are the most basic thing. Multiplication and division come next because they are built on addition and subtraction. And then exponents are repeated multiplication, right? So they're higher up on the hierarchy. Parentheses get to be first because we need parentheses to change the order of the other 3. Okay. So for example, say I have the numbers 2 and 3, and I want to add them up first and then square them, right? That's different than taking 2 squared, I'm going to put a not equal there, and taking 3 squared, or writing it without parentheses, 2 plus 3 squared. Each of these means something different. The first one here means, according to this order at least, take 2 plus 3 and get 5, then you can square 5 and get 25. If the square applied to them both, that means I have to do the exponent first. 2 squared is 4, 3 squared is 9, 4 and 9 is 13. Notice that's a very different answer than I have on the other side there. They don't match. And here, the 2 isn't anywhere near the square, only the 3 is because there's no parentheses. So this would just be 2 plus 9. I got to do the square first, and then I can add them and get 11, right? So the power of parentheses is it allows me to change the orders of the other things with this special grouping power. All right, so my belief is you're comfortable with the order of operations. Otherwise, you wouldn't have made it this far in math. And maybe you questioned like why it has to be this order. And there is a little wiggle room in that, but this is the most natural order of operations. Could we make a whole new math based on a different order of operations? The answer is yeah, sort of. But everything else would look different if we did that. All the rules that we use in algebra would look different. So this is what's believed to be the natural order of arithmetic on these basic operations. It turns out this also encompasses other kinds of operations that aren't specifically mentioned, but they're included, like the idea of a square root. It turns out that's a kind of exponent. A logarithm is also a kind of exponent if you've ever seen those before. And then there's these crazy things like you might have seen in math courses, things called sin, which means sine or cosine. And it turns out there are geometric ways that these other things fit into the order of operations. But just talking about basic arithmetic, that's the reason, because of the evolution of arithmetic itself. And so there's just a few homework problems where you get to just practice making sure you got that idea down, because you're going to be teaching it soon. All right, so there's really not too much else to say about those there. So there's a couple of things I wanted to review. So let's do some review next. Stop the recording here and then make a new one.